Hello, welcome to today's lecture on managing in competitive and monopolistic markets. So, as usual, I like to look at what's happening in the news. This is an article from this past week on the homeowners insurance market in Oklahoma and the Commissioner of Insurance claiming that it is a competitive market. Consumers were complaining that prices were too high and that there wasn't enough competition, but according to the Commission statistics, they claim that it is competitive. And this week, Meta actually won their antitrust case, or the antitrust case against them, where the judge ruled that they do not have a social media monopoly in spite of their acquisition of Instagram and WhatsApp. So, learning objectives this week, we want to look at the different types of markets. At the end of last lecture, we said there are 4 different types of markets. We're going to look at 3 of them in this lecture, and then we'll look at the 4th, which is oligopoly, in the next lecture. But in this lecture, we're going to look at perfect competition, monopolies, and monopolistic competition, and how firms behave under each of those, particularly as it comes to pricing strategies. We'll look at what are the sources of market power, how does that influence our pricing decisions, and how do we use the marginal revenue and marginal cost concepts in these 3 types of market structures. So first, we're going to look at perfect competition, then we're going to look at monopoly, then we'll look at monopolistic competition, which is in between those 2. So in a perfectly competitive market, there's many buyers and sellers that are basically selling the same thing. Each buyer and seller is relatively small in terms of market share. They're each producing, at least the producers are producing a homogeneous, identical product, and the consumers are all buying that same product. We assume to have perfect competition that buyers and sellers have perfect information. There's no hidden information that the buyers or sellers are not aware of. There's no transaction costs, so it's very easy to buy wherever we want to buy. And there's free entry and free exit into the market. Those are obviously some extreme restrictions, which are unlikely to all happen in real life, but it gives us an idea of looking at what a really competitive market would look like. So in this particular case, there's going to be a single market price. We're actually all going to be selling at exactly the same price because we're selling the same product. There's no transaction costs. There's free entry, free exit. And so there's no way we can charge more because people simply won't buy our product. They'll go buy it elsewhere since it's the same. Similarly, we don't want to underprice our product. We would get lots of sales, but over time, that's probably going to be below our cost, as we'll see in a minute. So theoretically, in the long term, firms in a perfectly competitive market are going to have 0 economic profits. Remember, economic profit is different than accounting profit. Doesn't mean we have 0 profits. It means we're earning enough profit to satisfy our owners, but that's it. We're basically providing our owners with the required rate of return, assuming we consider that capital cost to be part of our overall cost. So in a perfectly competitive market, there is a supply and demand curve, but that sets the overall price for everybody. So at the firm level, our demand is going to be equal to the price. In other words, we can't determine the price. The market determines the price. We're stuck with it. And so we're going to sell whatever we're going to sell based upon that particular price for our output. Since the demand curve is perfectly elastic, the pricing decision for us is trivial. We're going to just charge what everybody else charge. And at that price, we're going to determine how much output we're willing to supply. So what really matters for us is not the demand curve, but the supply curve. Basically, where that price intersects our supply curve is going to determine how much output we're going to produce. So recall the short term is when there are fixed costs And we're going to use those in calculating how much output to produce in addition to our variable cost. And recall, our total cost line is the sum of our fixed cost and our variable cost. And it's going to start up here. That's the level of our fixed cost. And it's going to go up because there's going to be some increasing and decreasing marginal productivity on our variable costs. Those are going to vary a little bit from period to period. So we have this sort of curvy going up and down as we get increasing or decreasing productivity. That's our total cost line, variable and fixed. And then our revenue line is going to start at 0 if we sell nothing, and it's going to slant perfectly upwards. There's no curve in the revenue line because our price is always going to be the same. The price is set by the market. We don't have a choice. No matter what the market price is, that's going to be our price per unit. So our revenue is going to be simply that price per unit coming from the market times the quantity. So it's going to run up like this. All right. Our maximum profits are going to appear wherever we see on the graph. There's the largest difference between our revenue line and our total cost line. Okay. That's going to determine our profit maximizing output. Remember, we're not setting the price, so we don't worry about that. We're just going to take whatever the price is, and we're going to produce this quantity that gives us that maximum profit. All right. In this case, our marginal revenue is the price per unit because we can't affect the market price. So if we want to sell a little bit more, we're going to charge the exact same price per unit. So in this case, our marginal revenue is going to be the derivative of the price per unit times the quantity. And the derivative of that, the Q drops off. The derivative of that is the price. So in a perfectly competitive market, the marginal revenue is equal to the price per unit as set by the market. As with the other cases, our profit maximizing point is going to be when the marginal revenue equals the marginal cost. Since this is our revenue line, the slope of that revenue line, which is the price per unit, is going to be the same as the slope at this point on our cost curve. So that's how we determine that this is going to be our optimal profit. And we're going to work through this both algebraically and using Excel. So this is another way of looking at it. So the price is given, the price per unit is given. We don't have a choice there. The quantity that we're going to supply is going to be when our price or marginal revenue is equal to our marginal cost. So it's when this price line, which is just flat, is going to equal our marginal cost. That's going to give us our maximum profit. So to maximize profits for a perfectly competitive industry, we're going to produce the output where the price equals the marginal cost. So instead of saying marginal revenue equals marginal cost, for a perfect competition, we're going to set our production where the price per unit equals the marginal cost. So let's say that our cost function is 5 plus quantity squared, and everyone in the industry is selling the product at $20 a unit, so we don't have a choice on the price. What is the price that we should charge? Well, we want to determine we're going to charge $20, all right, but then what is the output that we should produce? So we don't have a choice on the price, we just accept the market price. The marginal cost is going to be the derivative of this cost function. So recall when we do a derivative here, the 5 is a constant, that's going to drop out. And this 2 is going to move to the front. So it's going to be the derivative of this cost function is 2Q. So the marginal cost is 2Q. The price is 20. So we set price equal to marginal cost. So 20 equals 2Q. We get 10 units. So for this particular example, with a price of $20 and this cost function, marginal revenue is 20, marginal cost is, well, it depends on what we set it out, but marginal cost is the derivative of this, which is 2Q. So we're going to produce 10 units. And so our profits at that point are going to be $20 times 10 minus the cost, 5 plus quantity squared. It's going to work out to be $95. All right. Let's look at it using Excel. So I just plotted out the formula here. Remember, the revenue is a constant price per unit. So it's simply $20 times the quantity we're producing. The cost function comes from the equation. So if we look here, our profit starts at 14, then 31, 46. It peaks at 95, and then it starts to go down again. So our optimal output is 10 units, given the price that's established by the market and given our cost function. All right. This looks at it graphically. Our total revenue line is going to be not curved. It's going to be a straight linear relationship. Then we've got our total cost line, and we've got our marginal cost is going to be at this point. That's going to be the point of maximum profit of $95, which would be a quantity of 10. The market price obviously is set at 20. This is total revenue on this graph, not the price per unit. So what if, when we draw that price line, the price line is below our average total cost? So recall, we can determine our average total cost, our average fixed cost, our average variable cost, our marginal cost, and we can graph those out, and they're going to look something like this. In the example we just did, the price that was set by the market was up here. So the price was actually above our average total cost and our average variable cost. Notice in this example, our price is in between the average total cost and the average variable cost. So what that means is if we produce at the same point where the price equals the marginal cost, then we're actually going to incur a loss. All right. But it's not as bad as if this price were below our average total cost. So we're actually covering some of our fixed cost if we produce at this level. So it would be okay. In this case, we're going to have a loss, but we're going to minimize our loss by establishing our quantity produced at the point where the price equals the marginal cost. We're going to lose money, but we're not going to lose as much as if we just shut down and we still had to pay those fixed costs in the short run. Now, in the long run, we can obviously get rid of those fixed costs. We're also concerned if our price that's determined by the market is below our average variable cost. So in this example, the price is lower. So the market price is lower than both our average total cost, which includes fixed cost, and our average variable cost, which does not. So this means we're really going to lose money. We're not going to cover any of our fixed costs, and we're going to be selling products below our average variable cost. In that case, we're better off just shutting down, at least in the short run, trying to figure out how we can produce at a lower cost or wait until market prices are more attractive. So here's our short-run decision-making when we have perfect competition. To maximize our short-run profits or minimize our losses, a perfectly competitive firm should produce where the price equals the marginal cost, provided that the price is above the average variable cost. If it's below the average variable cost, then we should just shut down our operations. So produce where price equals marginal cost as long as that price is above our average variable cost at that point on the curve. Now, that then brings us back to a supply curve. So it turns out that we're not necessarily going to want to supply goods at very low quantities, given that the market is setting the price. And so the point where the price equals our average variable cost, we're not going to supply below that quantity. So normally you would see a supply curve that's going to slope upwards from zero out to whatever. Well, not from zero. The fixed costs are going to be here. So slope upwards from our fixed cost. But in this case, remember, if the price is below our average variable cost, we're just going to shut down. So our supply curve is going to run from this point upward. We're not going to supply anything below this quantity if the price is below that minimum level. So for our individual firm, the supply curve is going to look something like this. And then that's just ours, or a perfectly competitive market. So there are many, many other firms. And so the supply curve for the market is going to be the sum of all of those individual firms' supply curves. So it's going to be a little bit flatter, not quite as steep. As firms enter and exit the market, then what's going to happen is that supply curve is going to either move to the right. If new firms enter, there's going to be more supply at any particular price. If they exit the market, there's going to be a lower supply. And so if firms exit, the price would if firms enter, the price would fall. If firms exit, the price would raise, which makes sense. It's changing the level of competition. So it turns out that in the long run, therefore, that's why in a perfectly competitive market, in the long run, our economic profit should be zero. Everything is going to come to an overall equilibrium when we consider all the firms that are out there. And that equilibrium is going to occur when the price is equal to the marginal cost and is at the point where our average costs are at their lowest level. So in the long run, perfectly competitive firms are going to produce a level of output such that the price equals the marginal cost, and that price is also going to be the minimum point of our average cost line. Okay, so that's it for a perfectly competitive market. Now we're going to turn to a monopoly. So a monopoly is when you have one firm that serves the entire market. So a typical example of this is a utility, at least on a local level. So where I live in Prince William County, I don't have a choice as to who provides my electricity. I could put in solar panels perhaps, but for the most part, I'm stuck with the utility that serves my particular area. And so they have a monopoly in this particular market. They may not have a monopoly nationally, but they have a monopoly in this particular market. So when you're the sole seller of a good in a particular market, that gives you a lot of market power. All right. However, there still is a market demand curve. And so if the price of electricity were to get too high, I will consume less. So I'll turn off the air conditioning. I'll use gas heat instead of electricity for my heating. So there still is a demand curve, and we're bound by that demand curve. So we don't have unlimited power, but we do have a great deal of power in terms of pricing. So there is a demand curve because we can change our price, but it may be consumers will demand less of our product unless it's something that's absolutely, absolutely essential, and there's no way around getting a substitute for it. So there is going to be a downward sloping demand curve for a monopoly. So how do firms get monopolies? There's four main ways. Patents are legal barriers. So, for example, the utility has the concession from the government to operate in this particular area. It may be my homeowners association has other vendors that I have to use for certain things. So there's some sort of legal contractual regulation or patent that gives them that power. Another way of getting monopoly power is having such a huge economy of scale that nobody else can produce and sell at whatever the market price is. Another monopoly power is economy of scope. And that's where our firm is producing multiple products, and we're so big that the cost of delivering each of those products is less than what other firms can produce. Okay, so the three main ways to get monopoly power are patents or legal barriers, economies of scale, or economies of scope. There is a fourth, and that one's a little more complicated, so I moved this around. I'm doing it in a different order than the book did. So the last one is cost complementarity, and that's when the marginal cost to producing one product is reduced when we're also producing another product that's related. So some examples. Let's say that I'm a news organization and I've got to spend money to collect the news, to have reporters go out, get information, create the news articles. But I can produce that both in a print edition as well as an online edition. So I have two different products. They're not necessarily substitutes. For some people, they might be. But by having those two different products, I can spread the cost between those two products. So I'm spreading that cost over many different units. Another example is the airlines, who may run passenger flights as well as take cargo on those same flights, or also be running cargo flights. And then the cost of their hub, their operations, their repair and maintenance facilities can be spread between these complementary products. Another example is a bank. Banks offer deposit savings accounts, different types of investment accounts, but they also give loans. But they're spreading the cost of operating the bank over those multiple products. So these are all types of industries where you can see monopolies. Newspaper, probably not the best example these days because there may be print monopolies, but there's so many online sources for news or pseudo news today that it may not be the best examples. But the airlines, at least for some hubs, may have a local monopoly, probably more like an oligopoly, and we'll come to that in the next lecture. All right, so you guys probably recall this graph, which is a little hard to understand, but this is the overall demand curve, and at some point in the curve, which is a straight line, there's going to be elastic demand, inelastic demand, and unitary demand. So recall, when our demand is unitary, basically -1, then that's going to be the point at which we're going to maximize our revenues. So as we move in this direction, our revenue is going up. If we move backwards from here in this direction, our revenue is going up, but there's going to be a maximum level of revenues, which is going to be when we're at unitary elasticity. So this is the demand curve. Our marginal revenue curve is actually going to be lower than that, and we're going to explain why in just a couple of minutes. So to do this, we need to have what's called an inverse demand function. So you may recall from the first roughly 4 or 5 chapters of the book, we were dealing with demand curves or demand functions, which basically said we determine the quantity that's demanded for our product relative to the price of our product, and that's a negative relationship. The higher the price, the lower the demand. It's also a function of the price of substitutes. The higher the price of the substitute, the more that's demanded of ours. It's also a function of income. The higher the level of income, the more that's demanded. So in that case, we had the quantity demanded as a function of the prices. Now we're going to reverse that. And so we want to know the price that we should charge given a certain level of demand. So price is on the left-hand side, the quantity demanded is on the right-hand side. So the way you read this is the price at a particular quantity is going to be equal to some intercept coefficient plus some coefficient times the quantity. A has to be positive, but B has to be negative for the same reason that there's an inverse relationship between price and quantity. Okay, so remember the demand curve is downward sloping. If we want to sell one more unit of our product, so if Q is going to go up, we want to sell one more unit, we're going to have to lower our price. So B must be less than 0. So the price is a function of some coefficient plus some coefficient times the quantity, where this coefficient must be negative. So given that the price per unit is going to be equal to A plus B times Q, our total revenue, we're going to take the price per unit times the quantity we're going to produce. So that's going to give us A times Q plus B times Q squared. So our total revenue line is going to be AQ plus B2 squared. Recall our marginal revenue is going to be the derivative of our total revenue, just like we had on the cost side in the earlier chapters. If we have A times Q, the derivative of that is simply going to be A. If we have BQ squared, the derivative of that is going to be 2BQ. So the formula for marginal revenue is going to be A plus 2BQ. And so because of that, our demand curve is going to be flatter, and our marginal revenue line is going to be twice as steep as the demand curve. So we're going to work through an example of that. And so for a monopoly, our marginal revenue is going to be lower than the price. What that means is for every additional unit I want to sell, the marginal revenue from that additional unit is going to be less than the current price. So when a firm has market power, we're going to keep increasing our output, but that's going to be lowering our price. All right. So marginal revenue includes that impact of the price going down to sell that additional unit. We can also calculate, besides using the derivative, another way of calculating our marginal revenue for a monopoly is to take the price multiplied by 1 plus the elasticity divided by the price elasticity, our own product's price elasticity. So don't worry too much about this, but in a nutshell, if our elasticity is -1, then our marginal revenue, this is going to be 1 plus a -1, that's going to be 0. So the whole thing's going to be 0. So our marginal revenue is going to be 0. Our marginal revenue is positive when our elasticity is less than 1, inelastic. Our marginal revenue is going to be negative, however, when we're between 0 and -1. All right, so let's do an example here. So we have a inverse demand function. The price is equal to 10 minus 2Q. So this has to be minus. Remember, there's a negative relationship between quantity and price. So if we want to sell 3 units, then what's the price we would be able to charge? You take 3, plug it into the equation, and we would get a price of 4. Okay, recall that the marginal revenue is going to be equal to A plus 2BQ. That's the derivative of the price formula, the overall revenue, total revenue formula. We plug that in, our marginal revenue would be -2. So that means for each additional unit that we want to sell, we're going to have to reduce our price per unit by $2. So overall, we're going to have a typical output rule. We're going to want to produce at the point at which our marginal revenue equals our marginal cost. And that's going to give us the point at which we have our maximum profit. Okay, the price is going to be the price that we can charge at that given unit of output. So we find the point of our maximum profits. That's going to tell us what our total revenue is. We divide our total revenue by that quantity, and that would give us the price that we're going to charge. So let's work through an example of this. So we have a price function where the price at a particular quantity is equal to 100 minus 2Q. The cost of producing a particular quantity is 10 plus 2Q. And we want to find out, assuming we're a monopoly, what is our preferred quantity that we're going to produce, what is the price at that level, and what is our maximum profit. So we're going to go through this step by step. So total revenue is going to be this equation times the quantity. This is the price per unit. Price per unit is 100 minus 2Q times the quantity is going to give us total revenue. So total revenue is going to be PQ times Q, which is going to be 100 minus 2Q times Q, which is going to be 100Q minus 2Q squared. Our marginal revenue is going to be the derivative of that, which is going to be 100 minus 4Q. So the Q drops out. We just have 100. The 2 comes to the front here, so it's going to be 4 times Q. So our marginal revenue is 100 minus Q. Now we can compare that to our marginal cost. Well, our cost function is 10 plus 2Q. If we take the derivative of that, the 10 drops off. That's just a constant, so it's 0. The derivative of 2Q is simply 2. So our marginal cost in this particular example is a constant. It's 2. So we want to find the point where the marginal revenue equals the marginal cost. So we take our marginal revenue, which is 100 minus 4Q, equals our marginal cost, which is 2. We rearrange that. We get 98 equals 4Q. We move the 4Q to this side. We subtract 2 from both sides. And that works out to be 4 into 98, 24.5 units. So the ideal quantity to produce if we're a monopoly is given by the marginal revenue equal marginal cost point of 24.5 units, assuming it's feasible to produce a half of a unit. So how do we get our price? We go back into our price equation, which said the price is going to be 100 minus 2 times the quantity. So the quantity is given now at 24.5. The ideal price would be $51. That's the profit maximizing price. So if we take our revenue, 24.5 units times 51, we get a revenue of $1,249.50. Our cost, plugging into that cost equation, works out to be only $59. So we would have a profit of $1190.5. And if I did this in Excel with the price function and the quantity function, you would get that exact same profit level, but we're just using algebra and the marginal revenue and marginal cost concept to figure out the point at which we can maximize our profit if we're a monopoly. So to summarize this, the monopoly is going to choose the quantity that they're going to produce where the marginal revenue equals the marginal cost, and then they're going to use that quantity to determine the optimal price to charge. They could charge less, but there's no reason to. We want to maximize our profits. We have market power, so we have the ability to charge, given the constraints of the demand curve, as much as we want. So it turns out we don't really care about the supply curve as a monopoly. We don't have to worry about it because we're a monopoly. We're worried about the demand curve. That's going to determine how much we can sell at each output. But we're not going to worry about drawing a supply curve for a monopoly. All right, now this brings us to the third possibility, which is a monopolistically competitive market. So there's many buyers and sellers similar to a competitive market, but they're not selling an identical product. Each one sells a differentiated product. So they really are different. The example that the book uses are fast food hamburgers. That's more of a monopolistically competitive market because not every hamburger is identical. The hamburger at McDonald's tastes different than the Burger King hamburger, or the Wendy's hamburgers, or the Five Guys hamburgers. These companies are each differentiating their product, so they're not selling exactly the same thing. We still assume in this type of a competitive market that there's free entry and exit, but McDonald's has a sort of a mini monopoly over the McDonald's taste and experience. Wendy's has a similar, within a competitive market, monopoly for those people that like Wendy's. So the key difference here is they're producing products that are similar, but they are somehow able to differentiate their product from other very similar products. So the pricing decisions are going to be a little bit different. So it turns out, though, the profit maximizing rule is going to be the same for monopolistic competition. We're going to produce a quantity such that the marginal revenue equals the marginal cost. And then we're going to use that to set our profit maximizing price. So in the long term, if we're in this situation, we're going to try and maximize our short-term profits. We're also going to try and minimize our short-term losses. If some companies are losing money, they may choose to exit the industry. So the long-run equilibrium here, if we look at our average cost line, our marginal cost line, and then we have the demand curve here, then our marginal revenue line, remember, is going to be lower than the demand line. It's actually going to be steeper, but it's lower. So the marginal revenue line, which is below the demand curve, is going to cross the marginal cost line at a particular point. This tells us we would just go upwards to this line to determine the price that we're going to charge and the quantity that we're going to produce. And we're going to be able to earn a profit in the short run, but not in the long run, because it turns out in the long run, our average total cost is going to equal our revenue. So in the long run, we're going to produce a level of output where our price is higher than our marginal cost, but it's going to occur where our average total cost is at a minimum for monopolistic competition. So this is because we have this differentiation in our product. So how can we differentiate our product? One is obviously by taste or looks, but we can also do it through marketing. So we can use advertising to try and build that brand recognition for our product to differentiate ours from everyone else. So we can actually look at something like the elasticity of the demand for our product relative to how much we spend on advertising. And so we can use that if we can measure that elasticity, and we're not going to do it in this course, but if we can measure the elasticity of the quantity demanded for our product, relative to the advertising on our product, and we can look at the price elasticity of our product, this can actually tell us how much we should spend on advertising. So it tells us an optimal amount to spend on advertising given how much our market responds to our advertising. So a lot to unpack in this chapter. They use a lot more than derivatives. They get into the calculus solutions. We don't need those. We can do this using simple algebra, assuming we know how to do the derivatives to get the marginal cost and the marginal revenue. So remember, we talked about 3 different market structures today: perfect competition, monopolies, and monopolistic competition. The rules are, generally, we're going to produce where the marginal revenue equals the marginal cost. That's true for a monopoly. That's true for monopolistic competition. It's also true for perfect competition, but there the price is not set by us. Our marginal revenue is equal to the market price. So the output rule is we're going to produce where the price equals the marginal cost. It just so happens that is also the marginal revenue when you have perfect competition. So price for perfect competition, price is equal to marginal cost, also equal to marginal revenue. In the case of monopoly, we're going to be able to price it above marginal cost. In the case of monopolistic competition, we can also price it above marginal cost. That's in the short run. In the long run, theoretically, in perfect competition, our economic profit should be 0. In monopolistic competition, our long-term economic profit should be 0. But for a monopoly, there is the possibility of earning long-term economic profits. So remember, economic profits of 0 doesn't mean no profits. It just means everybody's happy. We're satisfying our investors. We're satisfying our workers. We're satisfying our debt holders. We're earning enough to pay all of those folks. So the average cost relationship at this particular point where we're going to price our product, the price is going to be equal to our minimum average cost, which is why theoretically our profit should be 0. Monopoly, no such requirement. We can earn money. Okay, in general, for monopolistic competition, our price is going to equal our average cost, but that may or may not be our average minimum cost. So I would know this chart. This is going to summarize really the high points for the 3 different market structures that we talked about this week. The next lecture, which is also for this week, the next lecture will cover oligopoly.